The information in this video is drawn from the Practitioner's Guide to Force Plates, which highlights how to integrate force plate assessment into both clinical and performance environments. Force plates provide a way to objectively measure how force is produced, dissipated, and distributed during movement. Across rehabilitation and performance, they allow practitioners to move beyond observation and quantify key physical qualities, such as strength, power, asymmetry, and balance. In this video, we'll cover 3 key ideas: how to select the right tests based on the qualities you want to assess, what common force plate tests reveal about performance and injury, and how to use metrics and benchmarks to guide your decision-making. The goal is to provide measurable data that informs both rehabilitation and performance strategies. Force plates can assess a wide range of movements, but test selection should always start with the outcome of interest. Rather than trying to identify the best test for rehabilitation or performance, practitioners should identify the physical attributes that they want to measure and select the appropriate tests from there. For example, if the goal is maximal strength, isometric tests like the isometric mid-thigh pull or isometric squat may be appropriate. If the goal is power and explosiveness, jump tests like the counter movement jump or squat jump are more relevant. If the goal is balance and control, tests like the quiet stand or single leg stand provide insight into stability and postural control. Force plates are capable of assessing isometric strength, ballistic movements, functional tasks, and balance assessments. This versatility means the same system can be used across rehabilitation, performance, and general population settings. Jump tests are among the most widely used force plate assessments. The counter movement jump is particularly valuable due to its simplicity and broad application. While jump height is often the most recognized metric, force plates provide deeper insight into peak power, eccentric and concentric contributions, interlimb asymmetries, and rate of force development. These metrics allow practitioners to quantify whether an athlete relies more on eccentric loading or concentric power, whether one limb is contributing disproportionately to the other, and whether force is being produced quickly enough for sport demands. Jump testing is also widely used for return to play decisions, fatigue and readiness monitoring, and performance profiling. Force plates are also commonly used in isometric strength testing. Tests like the isometric mid-thigh pull provide insight into maximal force capacity, rate of force development, and overall neuromuscular readiness. These are particularly useful when movement is limited or when assessing maximal strength in a controlled environment. Isometric data can also be combined with dynamic movement. For example, the Dynamic Strength Index compares the peak force from the counter movement jump to the isometric mid-thigh pull to understand how well strength transfers to explosive movement. Force plates are not limited to strength and power. They can also be used to assess balance and functional movement. Tests such as the quiet stand, single leg stand, and range of stability assessments provide metrics like center of pressure excursion, frontal and sagittal plane displacement, and weight-bearing asymmetries. These tests are specifically useful in early stages of rehabilitation, neurological conditions, and return to function assessments. Functional tasks such as squats, sit-to-stands, and push-ups also allow practitioners to quantify movement quality and loading strategies during everyday tasks. Force plates are capable of generating large amounts of data. However, as a practitioner, it's important to understand exactly what to do with that data once you receive it. Common metrics include peak force and peak power, asymmetries, impulse, and rate of force development. These metrics can be applied to identify deficits, track progress over time, and guide intervention strategies. Importantly, force plate data should be compared against relevant benchmarks. This may include normative data such as VALD norms, specific rehabilitation criteria, or performance benchmarks set out by a team. For example, persistent asymmetry in a counter movement jump may indicate incomplete rehabilitation. Reduced peak power may highlight a need for strength or velocity-focused training. Changes in balance metrics may reflect improvements in postural control. Rather than predicting injury, Force plates support better decision-making by providing objective insight into how individuals are performing and improving over time. Force plates are most effective when integrated into existing workflows. Rather than replacing clinical reasoning, force plates can help practitioners identify impairments more precisely, develop targeted interventions, and track progress with objective data. Importantly, force plates do not need to slow down practice. Many users report that the additional insights improve efficiency in clinical reasoning, communication with patients, and long-term decision-making. Over time, this creates a more structured, data-informed approach to rehabilitation and performance. Force plates aren't just about collecting data. They provide a way to understand how movement is produced, how load is distributed, and how individuals adapt over time. By combining the right tests, meaningful metrics, and context-specific benchmarks, practitioners can make clearer, more informed decisions. That's the focus of the Practitioner's Guide to Force Plates, turning force plate data into actionable insights for practitioners. You can download this guide and more for free today at resources.vald.com. You'll find the link in the description below. And be sure to subscribe for more videos just like this one. We'll see you next time.